This video is Binomial Distributions Part 5. So we left off on the more about that Whataburger contest, and we went to our calculator and we found all the probabilities for all the possibilities if we bought 10 burgers and on how many we could win. And we could win anywhere from 0 to 10 free small fries. And then we use those probabilities in our calculator to calculate the probability of less than 3, more than 7, no more than 4, and at least 8, and we got the following probabilities. Now, again, the calculator did make things easier, but this got a little tedious. What if we bought 20 hamburgers and we wanted to know what the probability was that we would win less than 10? So you'd have to, not less than 10, let's say less than 19. So you'd have to add the probabilities of 0 all the way up to the probability of 18. And that would take a while. So is there an easier way? Yes, there is. If you will recall, when I introduced the Binomcdf function, there was also a Binomcdf function that we mentioned as well. It is found just beneath Binomcdf in the calculator. So to get there, you would do second vars and then you would choose Binomcdf. Now, what it finds when you choose this function and you put in an n, a p, and an x. Now the x here will have a slightly different meaning, but what it's going to do is it's a cumulative function, and it's going to start with 0, and it's going to add the probability of 0 plus the probability of 1 success plus the probability of 2 successes plus the probability of 3 successes, so on and so forth until it gets to the probability of whatever x is. So if we put in 10.25 and then we put in 4, it's going to add probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4, and that's where it stops. It stops at the probability of x. Now, this function will always go from 0 up. It's always going to add from 0 up. Now, if you will recall, that would work for this one, and it would work for this one for less than 3 and no more than 4, but it wouldn't work here for more than 7 when we have to add the probabilities of 8, 9, and 10 together, because this function starts at 0 and goes up. So in order for us to do one where we do 8, 9, and 10, what you have to do is find the complement of that. So if we want to find the probability that it is 8 or more, where we added the 8, 9, and 10, you would find the complement. What's the complement of 8 or more? So the complement is the probability of that not happening. So if it's not 8, 9, and 10, it has to be 0 through 0, 1, 2, 3, 4, 5, 6, or 7. So you'd find the complement using Binomcdf and subtract that from 1. And I'll definitely show you how to do that. So let's try this again. Same scenario, same questions, same exact questions, except this time we are going to use the calculator. Now, even though we use the calculator, it's so important to set this up first so it can help you to see what you should plug in to the calculator. So when we want the probability that less than 3 of the hamburgers will win a free small fry, what does that mean? Well, less than 3 are the numbers 0, 1, or 2. And when we have or is implied, we add the probabilities. Now, your calculator will do this, and we need it to start adding at 0 and stop adding at, oops, I meant to do a highlighter, stop adding at 2. So where we want it to stop, that is our x. That's our x. So we're going to do Binomcdf, we're still going to do 10 trials. We're still going to do 0.25 for our probability, and we want it to stop adding at the probability of 2. Okay? So I'm going to have to go off of this to pull up the calculator so I can show you. So we're going to go to stat. No, I'm sorry, we're not going to stat. We're going to go to second vars. We're going to choose Binomcdf minus b. So the next time I do this, I'll probably choose alpha b to get there quicker. Number of trials is 10. The probability of a success of winning a French fry is 0.25, and my x value is 2. Now I'm not finding the probability of exactly 2. I'm finding the probability of 0 through 2, 0, 1, or 2 together. So, and that gives us 0.5256. 0.5256. Alright, so if I go back to the screen, you'll see we got 0.5256, just like we got here, except this was much quicker. Okay, let's look at the next one. Find the probability of more than 7. So what am I going to add together here? I'm going to add together, I'm going to move it over this way, and you're going to see why in a minute. More than 7 is 8, 9, and 10. And as I told you before, the calculator is not going to do this. If we put in 8, let's say we put in 8, it's going to add the numbers, the probability 0 through 8. If I put in 9, it's going to add 0 to 9. If I put in 10, it's going to put 0 to 10. We just want 8 through 10. So since the calculator won't do this, let's find the complement. So what I do is I just write out all the probabilities in order. So the probability of 0, probability of 1, probability of 2, keep going, of 3, of 4, of 5, of 6, all the way up to the probability of 7. And then 8 would be next, 9, and 10. Now you can see all the probabilities here. Imagine the ones that I didn't have room to write right there. Where does this stop? This is the complement right here. The complement is this. That's the complement of the probability of 8 plus the probability of 9 plus the probability of 10. So what we can do is we can find the probability that I highlighted and subtract that from 1, and if I because all of these probabilities together, if I add all these probabilities together, it should add up to be 1 because of the rule of probability distributions. So if I find this probability here up through 7 and subtract that from 1, that should give me the probabilities of 8, 9, and 10 together. So how do we do this in the calculator? We're going to do 1 minus binom CDF 10.25, and then our x, where do we need to leave off? We need to stop at 7. Okay, so we're going to do second vars. We're going to choose B, 10.25, and we're going to do 7, and then paste, and we get our answer. Now this is not the answer, we need to subtract that from 1, so I can do 1 minus and type this in, or let me show you another little lovely trick. You can do 1 minus and then choose second negative, and above negative it says A and S, which stands for the answer you just got. So this substitutes this answer in here. 1 minus the answer gives me 4.158 e to the negative 4. That means we move the decimal over 4 places to the left, and I get 0.0004. Let me show you one other way. What I usually do is I just type this whole string right here in 1 minus Binomcdf. So 1 minus Binomcdf, second vars, choose B, or I would choose B. You need to check, yours might not be B. Put in the same things, and we get 0.0004 this way as well. Alright, so let's look at the next one. What's the probability of no more than 4? No more than 4 is 4 or less, so we need to add the probabilities of 0, 1, 2, 3, and 4. So can we use the Binomcdf function? Yes, because we're adding the probabilities from 0 up to 4 successes. So for Binomcdf, or not PDF, CDF, Binomcdf, we do not have to subtract from 1 here because it starts at 0 the way we want it to. Okay, so 10.25, and we want it to stop at 4, so x is 4. So second vars, choose Binomcdf, 10.27, and we get 0.92187, which is 0.9219. Oops. Okay, and then the last one, at least 8 is 8 or more. We already did that. That's just like what we did up here on this one. You would do it the exact same way and get 0.0004. Okay, your turn to try it. Why don't you go through these and pause the video, see if you can work these out, write out what you would put in the calculator, and then unpause the video to check your answers. Okay, here we go. For exactly 10, we would do Binomcdf. 15.8110 is 0.0904. For exactly 12, we do Binomcdf. 15.8112 and get 0.2489. For 11 or fewer, that's 0, 1, 2, 3, 4, all the way up to 11, you're going to do Binomcdf 15.8111 and get 0.3146. For fewer than 10, that's 0 up to 10, so Binomcdf 15.8110 and we get 0.1394. And then for more than 9, we need 10, 11, 12, all the way up to 15. It does not include 9. It's 10, basically 10 or more. More than 9 is 10 and up. We have to find the complement. If we want to find 10 and up, the complement goes from 0 up to 9. 9 is just before 10. So we do 1 minus Binomcdf 15.819 and get 0.9510 when you round. And then 11 or more would be 11 and up. So we would find the complement, which is 0 to 10, Binomcdf 15.1810, and subtract that from 1 and get 0.8606.